Alright, so I have x to the power of x is equal to x to the power of 2. So, to solve this, I'm going to first divide both sides by x to the power of 2. So then these two cancel out, and now I have x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, I can write that as x to the power of x minus 2. And this is equal to 1. Now, if I take the natural log, or ln, on both sides, I have ln x to the power of x minus 2 is equal to ln 1. And if you guys already know ln 1, that's equal to 0. So now I have ln x to the power of x minus 2 is equal to 0. So now this gives me, before all of that, now I can actually move this to the front, because if I have something in the form ln a to the power of b, I can move b to the front. So this is going to equal b times ln a. So if I move x minus 2 to the front, I get x minus 2 times ln x is equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0, and I have ln x is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2. And for ln x equals 0, I'm going to take e to the power of both sides. So now I have e to the power of ln x is equal to e to the power of 0. E to the power of ln x is simply x, and e to the power of 0 is 1. So my two solutions are 2 and 1. Alright, so in this problem, I have a to the power of a is equal to a. So to solve this, the first thing I'm going to do is I'm going to take the ln on both sides. So now I have ln a to the power of a is equal to a. And if I have something in the form ln x to the power of y, I can move this exponent y to the front. So this can equal y times ln x. So in this case, I can move a to the front, so this is going to equal a times ln a, which is equal to a. Which is equal to ln a, because I took ln a on both sides. Now, what I'm going to do is I'm going to subtract ln a on both sides. So now I have a times ln a minus ln a is equal to 0. And now if I factor out ln a, I get ln a times a minus 1 is equal to 0. So now this gives me two equations. I have ln a is equal to 0, and I also have a minus 1 is equal to 0. So for a minus 1 equals 0, all I have to do is add 1 on both sides, and I get a is equal to 1. Now for ln a equals 0, to get the value of this, I'm going to first take e to the power of both sides. So I get e to the power of ln a is equal to e to the power of 0. Now e and ln, these two cancel out, so now I get a is equal to e to the power of 0, which is 1. Well, I got a equals 1 again. So the actual thing, what I'm going to do, because there is another solution, is now instead of simply taking ln, I'm going to take ln of the absolute value on both sides. So now I have ln of the absolute value of a times a is equal to ln of the absolute value of a. Because remember, over here, I only took the ln normally, but now this is the absolute value. So now when it comes over here, I'm not going to have ln of a normally I'm going to have ln of the absolute value of a is equal to 0. And this means that a is going to equal 1 as well as negative 1. So these are my two solutions. Alright, so in this problem, I'm going to be proving that 3 plus 3 is equal to 5. So, to prove this, I'm going to first start with the statement 0 is equal to 0, which is obviously true because any number is equal to itself. Now, what I'm going to do is for my left-hand side here, my left-hand side 0, I'm going to rewrite this as 9 minus 9, which is obviously true. Any number minus itself is 0. However, for now, from my right-hand side, I'm not going to do the same thing. I'm going to instead write this as 15 minus 15. So this is obviously legal. 9 minus 9 is 0, 15 minus 15 is 0, so there are no issues there. Now, for my left-hand side, 9, this is the same thing as 3 squared. So I'm going to write this as 3 squared minus 3 squared. And for my right-hand side, 15, this is equal to 5 times 3. So I'm going to write this as 5 times 3 minus 5 times 3. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I have 3 squared minus 3 squared, and a in this case is 3, and b is the same thing as well, 3. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 5 times 3. Now, if I have something in the form a times b minus a times b, this is the same thing as a times b minus b. So I have 5 times 3 minus 5 times 3, and if I factor out 5, I get 5 times 3 minus 3. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 3. Now, if I divide both sides by 3 minus 3, these two cancel out, and I get 3 plus 3 is equal to 5, or 6 is equal to 5. And this is obviously wrong. Where the mistake is when I divided 3 minus 3 on both sides, because 3 minus 3 is 0. So this is technically dividing 0 by 0, which is not 1, but it has no defined value. So that's where this proof went wrong, and this is wrong.